to review that value of theta right there, you got to get, theta by itself. We end up taking the inverse sign on both sides. So you're going to take the inverse sign of 0.8191. And now that your calculator's in degree mode, you can go back and you can type that in. So you do second sine, and then you do 0.8191. You can close it if you'd like. Press enter. You're going to, for the sake of this lesson, round to the nearest degree. It's going to make your life a lot easier, okay? So for these 4 problems at the top, round to the nearest degree. In other words, this is going to be about 55 degrees. So the first value of theta is about 55 degrees. And you're going to call it theta 1. Because our goal for today's lesson is to find 2 values for theta that would give you that sign as an output. So what I'm saying is the sine of 55 degrees right now is about 0.8191. But there's actually also another angle that you could throw into your calculator, and it'll spit out 0.8191 back out to you. Our mission is to find that second value of theta today. But first, I want you to make sure you just found, for each and every problem as your warm-up today, I want you to just find 1 value of theta for the whole paper. Caution, on part 2, you want to make sure that your calculator, you switch the mode, because here, we also have to be able to do this skill in radians. And I know that that's the case because the directions say, hey, we want our angle to be between 0 and 2 pi, and those are radian measures. So when you get down to part 2, when you go to find theta 1, you want to switch the mode in your calculator. Okay, while you're finding the first value of theta, I'm going to take a minute to walk around, check off your 4 homework problems from last night, and then I'll show you how to find the second value of theta in just a minute. What's up, Joey? Yeah, so number 1, part A was 55. 1B was negative 15 degrees. A little problem with that one, though. Do you see what the problem is? Has to do with the domain that they wanted our answer in. Is negative 15 degrees acceptable? If you look up here. Are we allowed to get a negative if it's supposed to be between 0 and 360? No, so you have to find a coterminal angle. So 1 value of theta for this one's going to be what, Richard? Yep. So 345 is probably your best answer there. And that's because you can't really get negative 15 degrees, isn't in our domain. So you can write yourself a little note there. For number 2, A is the first value of theta. I got 29 degrees in there. And then B, I got 104 degrees. And then to talk about your radian measures, this you did have to round to 2 decimal places. So for theta 1 on 3, I got 0.17. And B, I got 2.2. For A, I got 0.02. And then B, oh, you get negative 0.73. But please keep in mind that that's not an okay answer. So for B, if you get negative 0.73 when you throw it in your calculator, oh, Madison, what's up? Are you in the right mode? Okay, so let's do that one together then. You're asking me about 4B and A, is that right? Oh, 3A was 0.17, B was 2.2. You got those, okay. 4A is 0.02, and then we were just talking about 4B, which is this problem here. So when you do, to get the first value of theta, when you do sine inverse of that side, when you punch those buttons in your calculator, what your calculator spits out at you is about negative 0.73. And again, the problem with that is that in this particular set of directions, they said they wanted theta to be between 0 and 2 pi. Well, negative 0.73, that's negative, that's not between 0 and 2 pi. So you actually have to find a coterminal angle. Does anybody remember what you add in radians to get the coterminal angle? Richard? Go ahead, Adam. 2 pi or 6.28. Yeah. So you'd go to your calculator and just add on 1 full revolution, or add on, 6.28, however you want to work it. So we do sine inverse. I always try to save my rounding till the end. I gotta switch my mode here. So sine inverse of it was negative, huh? Negative 0.6691. So 0.73 is of the negative variety is what you get when you do that, and then we have to find the coterminal, so I'm going to add on 2 pi. And we get about 5.55 radians, so definitely in quadrant 4 there. So that was 4B. 5A is about 0.87. 5B, again, you get negative 1.45 when you do it the first time, but then you have to add on your 2 pi. So to get that one, I did tan inverse of negative 8.144. Get that, and then you add on your 2 pi. So 4.83 radians for 5B. All right, and then number 6. Number 6 was tricky because they were giving you cotan. And as I look at my buttons here, you definitely don't have a cotangent button. But you can find tangent just by flipping the value of cotangent. So for 6A, let me show you the scratch work I would do. So for 6A, they tell you cotan of theta is 5.671, and we don't have a cotan button, so we have to figure out what this is in terms of tangent. We know that cotangent is just 1 over tangent, and that tangent is 1 over cotangent. So what I can do is find tangent by using that reciprocal identity that has cotangent in it. We know that tangent is the same as 1 divided by cotangent, right? So all I have to do is take this value that I found for cotangent of 5.61, actually this value I was given for cotangent, and plug it in. So I could just substitute that right into the problem. And I'll go to my calculator for this part. So I'm going to do 1 divided by 5.671. And that gives me 0.176. So right now I know that the tangent of theta is 0.176. And I can go ahead and now, in radian mode, figure out what theta, the first value of theta, might be by doing the inverse tan of that number. So you could do inverse tan. So second tan of my answer. We'll keep the rounding to a minimum. And we get about 0.175 radians for the first value of theta. So 0.17 is what that would round to. And you would do something similar for B. Talk about that. I'm going to let you try that one. What's up, Richard? Sure. Do you follow? Does it make sense to you, Richard? I don't have a cotan button, so I had to define it in terms of tangent.
I understand that. I think I understand what that is.
Okay. All right, so right now everybody should have theta 1 all done. Does anybody have any questions or blanks? Okay, so now on to theta 2. We're going to do a couple together. What we don't finish is homework. Your assignment for tonight is to finish this particular paper. You're going to do your theta 2s on the notebook paper, okay? So you can grab your little notebook paper that I told you to take out a little while ago. And now it's on to theta 2s. Now, me and my smartboard, I have, infinite amount of space if I want to. So I'm going to do the problems in the spaces where they would go if there was a little bit more space on this paper. But you're going to do all your theta 2s on notebook paper. Okay, so what I'm trying to tell you is that to be very, very honest with you, in 1A, I could type in the sine of 55 degrees, and I could get 0.8191 back out. True story. What's up, Adam? I didn't say it yet. I wanted everybody to try that first. So I'll talk about it in a little bit, Adam. So I had to, what I was trying to say is that I could type in the sine of 55 degrees, and I could get 0.8191 back out. Watch, I'll do it, just for your entertainment. Sine 55, enter. Oh, man. I think it was supposed to be sine 51, huh? Oh, thanks. That's what it was. I'm still in radian mode. See? I owe you candy, Madison. All right, so yeah, sine of 55 is what I was doing. There we go. 0.8191. Crisis averted. So we get 0.8191 as, you know, sort of a verification that what was on the paper isn't baloney. Now, honest to goodness, what I'm trying to show you today is that I could type in the sine of another angle here, and I would get 0.8191 back out. I need to figure out what the second value of theta is that will give me 0.8191 back out. So there's another angle I could plug in here and get that same answer. So here's how you do it. Right now, I would draw theta 1. So in finding theta 2, in order to find the second value of theta that would satisfy this equation, step 1 is to draw theta 1. So 55 degrees. You don't have to bust out a protractor or anything like that. What quadrant is 55 degrees in? Yes. Almost to the 60, so up there. So that's theta 1 is 55 degrees. Step 2, find the reference angle for theta 1. What is the reference angle for theta 1? Sometimes this part isn't needed. What's the reference angle for theta 1? Go ahead, Adam. It's just 55 degrees. Okay, not really very necessary in this particular problem because theta 1 was in quadrant 1. But step 2 is to typically find the reference angle. Here it's 55 degrees. Step 3, you need to draw that exact same reference angle in the quadrant that matches the plus minus of the original problem. For instance, in this problem here, what you need to notice is that sine was positive. It was positive 0.8191. Remember that when there's no plus in front of a problem, it is automatically positive. So here sine is positive. You want to draw your reference angle in the quadrant that has sine positive. So we know that sine, based on that all students take classes, if you need to write it down, you can, all students take classes. We know that sine is positive in quadrant 1. That happened. What other quadrant is sine positive? Fred, Tommy? It's positive in quadrant 2. So you're going to draw your 55 degree reference angle in quadrant 2. So I just came back 55 degrees from the x-axis. The actual value of theta 2 is the space between the x-axis and where I just drew this terminal side. So I came back 55 degrees from 180. So where did I stop this last angle? Good, Richard? Yes, and that is the second value of theta. So we did 180 minus our reference angle and got 125 degrees. So that's the value of theta 2. Now watch, it totally works. Remember we were trying to find sine values that would spit out, sine values of angles that would spit out 0.8191. So if I go to my calculator right now in degree mode, and I type in sine of 125, I actually do get the exact same answer. So you have a real quick way to check it. You just put it in the calculator, And make sure you got what the decimal was originally. So roughly 4 steps. All right, let's do it again. Let's get a little practice. All right, so in part B, I'm asked to find 2 values of theta that will satisfy that equation. One of them was 345 degrees. That was one of the values of theta 1. Now I need to find theta 2. All right, step 1 in finding theta 2 is to draw theta 1. So I have to draw the first angle. (345 degrees is just 15 degrees back from 360. So that's theta 1, and that is 345 degrees. Step 2 is to identify the reference angle. I see the reference angle, it's right here. The space from the terminal side to the nearest x-axis. We call that theta prime. How many degrees is theta prime? 15, good. Now you got to think about in step 3, so step 1 was draw theta 1. Step 2 is find the reference angle. Step 3, I have to put this reference angle in a different quadrant. So we have to think about all students take classes. Notice sign in the original problem is negative. Well, sign in quadrant 4 is negative. What other quadrant is the sign value or the y value negative? Good, Michael. Nice. I said it's quadrant 3. So I have to draw my 15-degree reference angle. Again, it's always 15 degrees from the x-axis because it's a reference angle. I draw my 15-degree reference angle in the quadrant. Michael told us it's quadrant 3 because y values are negative in quadrant 3. And now I need to figure out the value of theta 2, which is the measure ultimately of that angle. So basically it's 180 and 15 more. We had to go 15 more degrees to get to that angle. You got it? 195 degrees. So what we're saying is that if I did the sine of 345 and the sine of 195, I'd get the same answer, and it would be negative 0.2589. Just to show you that this is true, you could throw it in your calculator. So the sine of 345 in degree mode, and then the sine of 195 should give you those answers. So it works out. Questions about that? Yes. If it's in quadrant 4, it could be 360 minus. So in quadrant 4, we know that cosine is positive. If your original angle is in quadrant 1 and they're talking about the cosine, then you're going to have to use 360. So it's always 360 or 180, Madison, because it's the x-axis. Until we get to radians, and then it's pi or 2 pi, which is what we're going to do now. Okay, so I just taught you how to do it in degrees. It's the same exact step process. It's 4 steps, but we need to switch the mode in our calculator for part 2. So I'm going to show you part 2 real quick. Change it. Did you change it? We're going to go to radian mode now. So how do you do this with radians? So for instance, number 3. When you found, you did cosine inverse to get the first value of theta. For 3a, we ended up getting 0.17 as the first value of theta. So everybody has that on their paper. Step 1, you want to draw that value of theta. So we're going to draw theta 1. .17, that's a small little angle, not even at 1 radian, not even at 57 degrees. Theta 1 Real small angle in quadrant 1. So that's step 1. Step 2, find the reference angle. Well, what's the reference angle for this one? Rachel, you were just asking me about these types. What's the reference angle for this? If it's just a decimal like that. You don't remember? It's just 0.17. Okay. So in quadrant 1, the number that's there is always the reference angle. Remember the definition of a reference angle if you're stuck. It's always the distance from the x-axis to the terminal side. Well, in this case, the rotation from the x-axis to the terminal side is just 0.17. So that's done. Step 3, you have to draw this reference angle in the correct quadrant. So you got to think about your all students take classes. So right now my reference angle is this 0.17, and I have to draw it somewhere else. They're telling me cosine is positive. So in what quadrant should I draw this 0.17 radian reference angle? Do you know, Madison? Yeah, because cosine's positive there. Good job. So you just kind of swing it 0.17 down below the x-axis. So again, I just drew that theta prime, my reference angle, to be 0.17 below your positive x-axis there. Remember that the second value of theta that you're looking for, however, has to be between 0 and 2 pi. So I need to find the measure of that big angle right there. Essentially, this goes back to Madison's question from earlier. Is it always 180 that we work with? Well, here's the classic case of where I have to work with the positive x-axis, where the angle measures 2 pi. So to find the second value of theta here, I have to come back 0.17 radians from 2 pi. So I'm going to take 2 pi and subtract 0.17, or you could look at it as 6.28 minus 0.17. And here's the buttons. What'd you get, Joey? That's what I got. So, technically speaking, what I'm saying is you could now, that I'm in radian mode, do cosine of 0.17 and the cosine of 6.11. Whoop, syntax error. I typed something in wrong. 2 decimal points. And you get that same answer, the decimal that was in the original problem. What's up, Joey? Yes, these answers are in radians. Part 2 is all radians. What's up, Troy? Yeah. Okay, we're going to do one more together, and then, like I said, your assignment for tonight is to finish this paper. All right. This time around, cosine's negative. You already found the value of theta 1 as your warm-up today. The first value of theta for this is about 2.2. So step 1, you have to draw that angle. .2 radians, not quite to 3.14. So you're looking like up in here somewhere. This is 3.14 radians. 2.2 has to be back from that. After you draw theta 1, step 2 is to find your reference angle. Theta prime. How do I find my reference angle in quadrant 2? Good, Joey? Yeah. Good. Perfect. So to get the value of my reference angle, you're just going to do pi minus 2.2. So you can go to your calculator, do pi minus 2.2. We get 0.94 radians for the reference angle. So that's what that is in there. Okay. Cosine is negative, so now I'm going to think about this all students take classes. And I want to think, well, yeah, cosine is totally negative in quadrant 2, but where else is cosine negative? What other quadrant? No, Madison? It is quadrant 3. Good job. So I got to draw this same angle, basically, flip it into quadrant 3. So I got to come back 0.94, transplant my reference angle, so to speak, in the correct quadrant. So it's quadrant 3. So again, theta prime was 0.94. So to get the second value of theta, you got to go the whole way around. So you would just do pi plus your 0.94 to get the second value of theta. Okay, your assignment for tonight is to finish up this. You got to find all the theta 2's for me. We'll talk about that 6b a little bit more tomorrow also. And then tomorrow we start reviewing.